Music is a fascinating phenomenon with the power to create cohesion, influence arousal, and elicit rewarding feelings. It creates its own space and lets its participants join in synchrony and merges our experience of these sound patterns moving through time. Contemporary research has shown that music truly is a human universal, and wherever humans are, music can be found in one form or another. This odd human behavior is costly in terms of energy, skill, physical capabilities, and time, and the biological architecture in place needed to understand, appreciate, and engage in musical behavior is very specific and costly. This is the basis for a multitude of modern theories of the evolution of music, which emphasize that such a persistent and specialized behavior should not just be a byproduct of our intelligence, but something that gave us a definite evolutionary advantage. One line of thinking that is important for this idea is the notion of the functionality of song types and the universality of four song types: love songs, dance songs, healing songs, and lullabies, which was demonstrated by Samuel Meer's extensive study of human musicality in different societies across the globe. Lullabies are being sung in all cultures of the world to calm and soothe infants, and the theory of mother infant bonding emphasizes the biological benefits of singing and reassurance of the infant generated through auditory signals by lullabies. Infants are very sensitive to the absence of caretakers, and agitation and stress can quickly follow as a reaction. My hypothesis is that lullabies could function as a substitute for human affective touch when caretakers are unable to physically touch the infant. The idea is that lullabies emerged in a time where, due to various increasing factors like work, craftsmanship, and other activities, parents had to be separated from their infants more often, a problem that is also well known to modern multitasking parents. Humans have special nerves capable of registering stroking in a certain speed, 1 to 10 centimeters a second, and at a certain temperature, around human skin temperature, 32 degrees, and a certain context. These CT afferent fibers are sensible to affective human touch and are important for intimate human interaction and personal development. The similarity of brain regions that are activated through affective touch and through listening to comforting music suggests a possible link between the experience of these two phenomena. This leads to the two hypotheses of the study. The first one is the assumption of a universal tempo range for lullabies, regardless of origin, that is significantly different from another similar universal song type. Love songs were chosen as a comparison because, according to Samuel Meer's study, this type of song shares the features of lullabies by being slow in tempo and affective in nature. The second hypothesis is whether the speed of gentle stroking necessary to elicit the feeling of affective touch aligns with the tempo range of lullabies regardless of origin. To do this, I had to work with three methods to translate the physical velocity of touch into the auditory tempo of music that I will mention in a moment after explaining the methods and design of the study. The study was designed to be easy to navigate for people of all education levels and all origins, with the goal to get as many people from as many cultures, countries, and languages as possible as participants. To do this, I used the online form generator Yotform and created a template able to play pieces of sound, record voices, and receive written data entries, and this all on your smartphone, with just a link being sent around. Participants were asked to sing a lullaby, love song, and a song they would personally choose to fall asleep and answer a few questions about themselves, like age, gender, country of origin, and musical experience. A small refresh task was implemented in between the recordings to avoid the previous performance influencing the next one in tempo. Then I started gathering help to translate the study in as many languages as possible and make it more accessible to people of different education levels and origins. The effective touch tempo was ultimately determined using three methods. The first one was by using a tap meter tool, which is like a little software that helps you keep tempo with musical pieces depending on which meter you are in. So you tap along to a certain thing in 3 times per meter, 4 times per meter, depending on what you are using. So tapping along to videos of affective touch demonstration using a tap meter tool, the movement speed can be translated into different rhythms, and I picked the ones which are simple and the most common for lullabies, like the 2/4, 3/4, and 4/4 meter. The second method was used to synchronize my breathing with the affective touch movement of those videos and compose a simple melody in the tempo of this rhythm of breathing, in the tempo of this movement, and use that as a middle ground for the analysis. And ultimately, for the certain methods, I used widespread data of resting heart rate in infants and adults as reference, because ultimately this is where the lullaby tries to get the infant to a calm state of sleep with a resting heart rate that should be similar in tempo to the middle ground of the other two methods. Then I created a second data set consisting of 200 recorded lullabies and love songs from all over the world to compare the results of the recordings of my study with independent song recordings from both categories, love songs and lullabies. Both sets were analyzed for beats per minute, BPM, in Ableton Live, a digital audio workstation, and were examined and analyzed cross-culturally to see how fast the pieces of music are on average, and then to see whether this tempo aligns with the affective touch velocity that was established through the 3 methods I just mentioned. And in just a moment, my colleague and friend Yasemin Abra will show you the results and help explain what we found with the data of the study so far. Thank you.
All right, so here is the summary of our dataset, both the repository and the experimental dataset, as Ben has explained, as count per continent. This is important as we will be using continent as our clustering variable. Please also note that we have lullabies and love songs in equal numbers from each continent. These are the box plots for both datasets showing the tempi in beats per minute for lullabies and love songs per continent, with red denoting lullabies and blue love songs. Already by looking at the plots, we can see that love songs are faster in average and have a greater variance per continent. We wanted to know if the tempi of lullabies and love songs were different per continent, and thus ran a two-way ANOVA, both on the repository dataset and the experimental dataset. The two-way ANOVA on the repository data showed that song type was significantly associated with different tempo. Continent was not associated with significantly different tempo, and the relationship between continent and tempo depended on the song type. The two-way ANOVA on the experimental data showed that song type was associated with significantly different tempo, that continent was associated with significantly different tempo, with the Tucky test showing a significant difference between North America and Africa. And again, there was a significant interaction between continent and tempo. We then wanted to know whether the tempi of lullabies and love songs were significantly different from the affective tempo, which is 67 beats per minute per continent. Again, here we see the box plots for both datasets. The y-axes show the difference between the baseline, which is 67 BPM, and our data points per continent. So we asked the question, are tempi of lullabies and love songs different from the affective tempo per continent? And again, we ran two-way ANOVAs on both datasets. The two-way ANOVA on the repository dataset showed us that neither continent nor song type was associated with significantly different distance from the affective tempo. But on the other hand, our experimental data showed that both continent and type of song were associated with significantly different distance from the affective tempo. All right, that was the end of our preliminary data. As this is an ongoing project, we would like to share with you some of our next steps. We most certainly would like to collect more data from participants from all around the globe. This would not only help with the robustness of our analyses, but also allow us to come up with other potential clustering parameters underlying universality. The experimental data includes fluctuations in the tempo, and we would like to find a way to integrate that into our analyses. We would also like to use the experimental data to look at the effect of such factors as language and whether the participants have children. If COVID regulations allow, we would also like to hold in-person testing sessions where the caregiver would sing to the baby in real time, which would allow us to integrate the baby's arousal state and how sensitively the caregiver adjusts to that in tempo. Thank you very much for watching this video. If you have any questions or comments, we would be more than happy to hear them. In that case, please reach out to us via email. We are very much looking forward to hearing your input.